All right. Before we go on, there's a couple of terms we need to get straight while we talk about caching. And one is what's called the architectural view, and then there's the non-architectural view. So what we're talking about when we say the architectural view of memory is what the machine language sees. The architectural view, in other words, the architectural view is how everyone thinks of memory up to this point. You just think of it as a giant array, and you're accessing certain parts of memory, and you're loading from them, saving off to them, working with them. Now, we're going to break that apart. We're going to still give you the interface, or the illusion, so to speak, of the architectural view of memory, aka give you the illusion that it's just one giant array of memory, but we're actually going to implement that array with non-architectural features, namely a cache or whatnot. Now, this is something that the programmer doesn't know about because they don't need to know about. We're just implementing the interface of the whole memory structure as one giant array. And the new implementation may not break it up into the same pieces or break it up at all, depending on how we go about it. But the reason why this is important is the architectural view, or the way the programmer codes, is that memory is one giant array, but the hardware architect is allowed to break that up and change it into whatever it needs to be, as long as they're able to implement the architectural view. All right. Whew. So what does a cache do? Holds the data that we think is most likely to be referenced, in hopes that you will use it, and then you take it from the cache as opposed to main memory. Why? Because we want to maximize the number of references that are serviced by the cache to minimize the average memory latency. So the question is, how do we decide which accesses we would like to see? Well, we have to run a bunch of statistics. But before we go on, let me give you a quick analogy. Let's say, for an example, you're hungry, and first thing you need to go eat. So option one, you usually go to the refrigerator. Latency is probably a minute, because you got to find something in the fridge and then go ahead and eat it. But if your fridge is empty, hopefully you go to the store, and hopefully the store still has food. I went to the store yesterday, and all the ground beef was gone. It's interesting.
These are things people buy.
The bread and the ground beef were gone. The fruits and vegetables all over the place, but all the canned stuff was still there. I was thinking, if you want to stock up.
People buy tons of eggs for some reason.
Costco had the same thing. Like, all of Costco's organic ground beef was gone. It was just the giant, like, 6-pound, like, blocks that they sell that was left.
Oh, that's hilarious. Well, to me, it seems like you'd buy all the canned stuff, right? Because that doesn't perish. Wouldn't that be what you go for? Anyways. So you go to the store, and hopefully it has some food. It may take you 20, 30 minutes because you got to go to the store and you got to come back. Option 3 will be to grow your food. You plant, and then you wait forever. And then what's the latency on that? 6 months? Yeah, 6 months. Anyways, the point of this analogy is the refrigerator is like the cache, where you try and keep everything nearby that you want to access. The store is like main memory, where it's annoying to go there, but you can get it done, and you'll be done with it. Hopefully you bring back a lot more than just a little food, so you can keep it in your fridge. And then option 3 is if you have to go to the hard drive, because that is pretty much how long it takes relative to the computer's speed in order to access something from the hard drive. So, and now we have to do the lovely class problem that unfortunately is only me. So, let's see what we can do here. Given the following, so we have a cache with 1 cycle. All right. And then we have, what's the next one? Main memory. All right. And that has 100 cycles. And then the last one is disk. And let's see, what does that one have? 10,000. Okay, so the question is, we have 100 memory references, 90% are cache. And we go over here, 90%. And 80% of the access to memory, 80% here. Okay, let's go ahead and, let me take this off real quick. If I can't. All right. Okay, so the idea here, cache takes 1 cycle, main memory takes 100, disk takes 10,000. We have 100 memory references. 90% of them go to the cache, which means they'll be serviced in 1 cycle. And then 80% of the leftover ones are going to go to main memory and take 100 cycles. And then what's left over goes to the disk. So how do we figure this out? Well, 90% of the 100, so 0.9 times 100, because we had 100 cycles, is going to take 1 cycle. So that's the cache. And I will explain that again. So we have 100 memory references, 90% of them, so 0.9 times 100, take 1 cycle because that's the cache. All right. Now, well, what's left over of that is 80% of 0.9 times 100.
Basically locks down the rest of your computer so that they know you're not able to.
I did not catch that. Was that background sound or someone trying to say something?
That is a good question.
Okay, then I will move on.
That disembodied voice.
It really did. All right, so 90% of 100, that's what's over here, times 0.8. So that's going to be the leftover memory references to main memory, so that'll be 100. And then what's left over? Well, let me go ahead and help you out here a bit. So 0.9 times 100, that's 90. And then again, 0.9 times 100 is 90. Oops. And I don't know why I put 0.8 there, but I sure did, because I was probably just distracted or something. But what's left over here is not 0.9, but 0.1 times 100, which is, of course, what is that? 0.1 times 0.8 times 100. What is that? That's 0.08. Yeah, so that'll be 0.08. And so we got 0.9 here, 0.08 here. That means we have 0.02 left times 10,000. All right, we're going to add that up. Quick, someone do that for me. I really wonder what's going on right now.
Literally everyone is muted. I don't know where the noise is coming from.
Yeah, it's interesting. Let's see, 0.08 plus 8. And then 2,000 times 2 plus 200. So that should be 298 by my calculations. So the point of this, ooh, someone is really speaking up right now. Who is it?
As he said, everyone's muted, and it's not flashing whenever it's yours, so...
Huh, I wonder what's causing it then. Wait, if I keep talking, does that stop it from letting other people talk at the same time? I do not know if I can keep this up. That might be a long time.
No, people can talk over each other.
Okay, well then.
Yeah, it's perfectly fine. We're doing it right now.
Excellent. So, the point here... Anyways, the point here is the 200, which came from the 10,000, is the dominating term over the cache and the main memory, which means that the disk is what dominates it, even though the disk only took up a very small section or a very small percentage of the memory accesses. The point of this exercise is to point out that if you are trying to do a memory problem, it is imperative that you minimize the accesses to the disk. Do I need to mute? Maybe it's me. Let me mute myself real quick.
Mute is right next to your name.
It is not me.
Oh, that is disturbingly weird.
It really is.
Yeah,
It's gotta be some sort of, like, really weird software Discord issue. Because even
do we have a ghost in the channel?
because even when Dr. West mutes and if I mute his like stream, so literally everything in Discord is muted, I still hear it.
Okay, because I was wondering maybe it was coming from his stream, but not from his voice. Because I thought maybe sharing his computer sound.
No, when he muted, it shouldn't have done that. So, is there like a ghost in the channel or something? Like, is there another person unmuted?
And a few people are unmuted right now talking, but it's not anyone in here.
It's definitely a ghost then. So weird. It sounds like almost like another classroom, like somebody's having another discussion.
Yeah, I don't really, hold on, I'm just gonna start muting people.
It honestly, it does sound like a classroom or something.
Like, it sounds like someone else's room.
Yeah.
So weird.
Dr. West, do you want to try stopping the stream and then starting it back up?
Yeah, let me do that. Let me pause the recording.